Good morning, dear students. Welcome to Unacademy, welcome to Kreatryx channel, and welcome to Impulse batch.
Morning, dear students.
Before going to start today's session, let me introduce myself. I'm Swamy. I've done my MTech in Systems and Signal Processing. I have 12 plus years of teaching experience, and my favorite subjects include Signals and Systems and Communication Systems. And currently, I'm associated with Unacademy. And if you want to purchase any course on Unacademy, you can use my referral code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions here, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his choice of educator. And we have rank improvement batches also. Coming to the next subscription known as the Iconic subscription, here a personal coach is allotted to the students who will prepare the study planner. Study booster sessions are there. Separate test analysis is taken for each and every student. Dedicated doubt clearing instructors are there, and preparatory study material is also given to the students. Coming to the fee structure, if a student is planning his GATE or ESE preparation in Plus subscription for 12 months, that is 1 year program, this costs around 27,225 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 18 months, that is 1.5 year program, this costs around 34,650 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months, that is 2 year program, this costs around 39,600 rupees only after applying the code KVS Live. Coming to Iconic subscription, GATE or ESE preparation in Iconic for 12 months, that is 1 year program, this costs around 45,225 rupees only after applying the code KVS Live. GATE or ESE preparation in Iconic for 24 months 2 year program, this costs around 66,600 rupees only after applying the code KVS Live. And let me tell you an important information that every week Unacademy is conducting an online exam known as Unacademy Combat, and this is going to happen on the coming Sunday also, that is 6th of June for the branches of Mechanical, Civil, Electrical, Electronics and Communication, Computer Science and IT. And this is what is known as your Unacademy Combat. And the advantage with this Unacademy Combat is that if your rank is in between 1 to 3, you will be getting 100% discount on the Plus subscription. If your rank is in between 4 to 10, you will be getting 75% off on Plus subscription. If your rank is in between 11 to 50, you will be getting 50% off on Plus subscription. And if your rank is in between 51 to 100, you will be getting 25% off on Plus subscription. So in order to write this Unacademy Combat, you can use the code KVS Live. And these are the currently running batches for GATE 2022 Evolve batch, and for GATE 2023 Ascent batch for electrical engineering. And these are started on 26th of May, and you can take a subscription in any one of the batches you like. And coming to ECE part, so we have Evolve batch for 2022 ECE and Ascent batch for 2023 electrical. And Unacademy is giving you one more opportunity to practice 10,000 questions in the form of a Master Blaster practice series, and these are free special class series for the branches of Computer Science, Electrical, Electronics and Communication, Mechanical, Civil and Chemical. Try to utilize this opportunity, my dear students. These are held in the form of special classes, and for this also you can use my code KVS Live. Good morning, Thiru, Vamsi, Ashok, Manoj, Fazal, Harish. Now let's start the topic. See, In the last class, we were discussing the properties of Laplace transform. We are done with linearity, time shifting, time scaling, shifting in S domain, time reversal property we have seen, differentiation in time we have seen, differentiation in S domain we have seen. Now, if I ask you from the last class, if I ask you one question, what is the Laplace transform for this one, t power n minus 1 by n minus 1 factorial e power minus a t of t 1 by s plus a whole power n with ROC sigma greater than minus a. Hope all of you remember this. From this, if I ask you, what is the inverse of 1 by s plus a whole square? It is nothing but, here substitute the value of n to be 2, t e power minus t u of t, t e power minus t u of t, right? Hope everybody remember this. Now let's start or discuss the next property of Laplace transform, which is an important property, convolution in time. Convolution in time property. This property says that if the signal x of t forms a Laplace transform pair with x of s with ROC R1, h of t means impulse response of the system forms a Laplace transform pair with h of s with ROC R2, then x of t convolved with h of t, that is output of the LTI system, forms a Laplace transform pair with x of s multiplied with h of s with ROC containing R1 intersection R2, ROC containing R1 intersection R2. In the statement, what we are going to give here is convolution in time domain, convolution in time domain is equivalent to multiplication in S domain. Multiplication in S domain. Similar kind of statement we have seen in continuous time Fourier transform. No, convolution in time domain is equivalent to multiplication frequency domain we have seen. Here the statement is convolution in time domain is equivalent to multiplication in S domain. And remember this h of s, which we obtained, capital H of s, which we obtained by taking the Laplace transform of impulse response, is known as transfer function. Transfer function. Continuous time Fourier transform of impulse response gives frequency response, whereas Laplace transform of impulse response gives transfer function. Transfer function. Transfer function is nothing but the Laplace transform of output divided by Laplace transform of input, considering the initial conditions to be 0. If you want to find out the Laplace transform of any system, you must consider the initial conditions to be 0. After that, you take the Laplace ratio of Laplace transform of output to the Laplace transform of input. Laplace transform of output to the Laplace transform of input is nothing but transfer function. Right. Now we'll see the applications of this convolution in time property of Laplace transform. What are these properties saying? Convolution in time domain is equivalent to multiplication in S domain. First application is, look here. What is the Laplace transform for u of t? 1 by s. What is the Laplace transform for u of t? 1 by s. ROC sigma greater than 0. Take one more u of t. What is the Laplace transform? 1 by s. ROC sigma greater than 0. Now do one thing. Convolve these two signals in time domain. If you are convolving in time domain means in S domain you have to multiply, and ROCs you have to take the intersection. Now what happens if I take the intersection? Sigma greater than 0. And what happens if I multiply? What happens if I multiply this Laplace transform? 1 by s square. Now from your previous property, that is differentiation in S domain, already we have seen what is the inverse of 1 by s square? For sigma greater than 0, it is nothing but R of t. But what is from LTI systems, what is u of t convolved with u of t? R of t. Means this is one more way of finding the convolution of continuous time signals. If you want to find the convolution of two continuous time signals, do one thing. Calculate their Laplace transforms, multiply their Laplace transforms. To the resulting Laplace transform, find out the inverse Laplace transform, that is nothing but convolution result only. Akash Kumar, it is very important. One more example we'll see. What is the Laplace transform for e power minus at u of t? 1 by s plus j. What is the ROC? Sigma greater than minus j. Already we have seen. Take one more e power minus at u of t. What could be Laplace transform? 1 by s plus j. ROC sigma greater than minus j. Now do one thing, convolve these two signals in time domain. If you are convolving in time domain means multiply in S domain, ROCs you take the intersection. Now what happens if I multiply the Laplace transforms? 1 by s plus j whole square, ROC sigma greater than minus j. Just now we have seen in the starting of the class, what is the inverse of 1 by s plus j whole square? It is, sorry, this is t e power minus at u of t. Here minus at will come, t e power minus at u of t. So t e power minus at u of t. But from LTI systems, what is e power minus at u of t convolved with e power minus at u of t? It is t e power minus at u of t. So you can find out the convolution of two continuous time signals in this manner also. If you want to find the convolution of two continuous time signals, calculate their Laplace, multiply their Laplace. To the resulting Laplace transform, find out the inverse Laplace transform, that is nothing but convolution result. Convolution result. X of t, Laplace transform is x of s. Del of t, Laplace transform is 1. Now convolve these two signals in time domain. If you are convolving in time domain, multiply in S domain. What happens if I multiply in S domain? X of s. What is the inverse of x of s? X of t. But from LTI system, what is x of t convolved with del of t? X of t. Convolution of a signal with an impulse signal gives the same signal, no? Hope everybody is getting. Right? A previous question was given like this: solve y of t plus integral 0 to infinite y of tau x of t minus tau d tau is equal to x of t plus del of t. X of t plus del of t. Now we have to solve this how to solve this one? Applying Laplace. What is the Laplace transform for y of t? Y of s. And what is this operation? This is convolution, and we know that convolution in time domain is equivalent to multiplication in S domain is equal to x of t Laplace transform is x of s plus 1. Now do one thing, you take y of s common, x of s plus 1 is equal to x of s plus 1, or y of s is equal to 1, yt is equal to del t. Shall I give you one more problem? You find out the convolution of eight cos 2 pi t u of t come on, try to solve this one. I want the convolution of these two signals. Convolution of this signal with this signal I want. These kind of problems will come in the exam. The hint is use the convolution property of Laplace. See, if you want to find the convolution of these two signals, do one thing, calculate the Laplace, multiply the Laplace. To the resulting Laplace transform, find out the inverse Laplace. That is nothing but convolution result. Try to solve this problem, my dear students. Okay. How to solve this problem? You cannot type your answer in the live chat, so I'll give the answer, you can cross verify. Now, from the property, if I want to find out the convolution of these two, first of all, I must calculate the Laplace transform. So these two signals are convolved in time domain, means in S domain they are multiplied, first point. First signal and second signal are convolved in time domain, means in S domain they are multiplied. Do you remember what is the Laplace transform of cos 2 pi t u of t? Or we know, right? Cos omega naught t u of t, we have seen cos omega naught t u of t forms a Laplace transform pair with what? S upon s square plus omega naught square, isn't it? Now, what is the Laplace transform here? S by 8 times s by s square plus 4 pi square, right? Now, what is the Laplace transform for the second one? U of t minus 1, means you have to use linearity and time shifting at a time. U of t means 1 by s minus u of t minus 1 means use shifting property, e power minus st naught into x of s. Or the next step becomes 8s by s square plus 4 pi square multiplied with 1 minus e power minus s by s. Hope everybody is comfortable up to this step. Now here what will happen? This s gets cancelled, right? Now how you can simplify this one? How you can simplify? Can I write this as, if I bring this 8 outside, or observe here, this can be written as 8 by s square plus 4 pi square minus right. Now further I can simplify this as 8 times 1 by 2 pi 2 pi by s square plus 4 pi square minus 8 times 1 by 2 pi I am dividing and multiplying by 2 pi. Now what? Now find out the inverse. Now we calculated the Laplace transforms, multiplied the Laplace transform. Now to the resulting Laplace transform we have to find out the inverse. Now what is the inverse? Now the resulting signal is x of t. So 4 by pi, what is the inverse of 2 pi by s square plus 4 pi square? Alright, do you remember sin omega naught t u of t? Sin omega naught t u of t Laplace transform is omega naught by s square plus omega naught square with ROC sigma greater than 0. So omega naught by s square plus omega naught square, this becomes 4 by pi sin 2 pi t u of t minus, now 4 by pi, what is the inverse of e power minus s times 2 pi by s square plus 4 pi square? You have to use the shifting property. Observe here my dear student, this is very important. What is the shifting property saying? Last class we have solved this kind of problems also. X of t minus t naught forms a Laplace transform pair with e power minus s t naught into x of s. Our inverse of e power minus s t naught into x of s is x of t minus t naught. How to get the inverse of e power minus s t naught into x of s? First of all, to this x of s, get x of t first. In this x of t, wherever you have t, replace it with t minus t naught, I said. T minus t naught. In a similar fashion, now what is that we are having here? Okay, fine. E power minus s multiplied with 2 pi by s square plus 4 pi square. This is what I am having. Now can you tell me what is the inverse? Now we compare this with e power minus st naught into x of s. What is then in place of t naught? 1. What is then in place of x of s? 2 pi by s square plus 4 pi square. Now do one thing, to this x of s, get x of t first. What is that x of t? Sin 2 pi t u of t. In this x of t, wherever you have t, replace with t minus t naught. Sin 2 pi into t minus 1 u of t minus 1. It's as simple as that. Right, so inverse becomes minus 4 by pi u of t minus 1. Hope everybody is comfortable. Next question. Given y of t is equal to x1 of t minus 2 convolved with x2 of minus t plus 3, where x1 of t is equal to e raised to minus 2t u of t and x2 of t is equal to e raised to e power minus 3t u of t. Find y of s and specify ROC. Find y of s and specify ROC. Come on, try to solve this one. It's an important problem. y of t is x1 of t minus 2 convolved with x2 of minus t plus 3, where x1 of t is this signal, x2 of t is this signal. He is asking us to calculate the Laplace transform y of t, that is y of s, and you must specify the ROC as well. No need fuzzle. Observe here. How to solve this one? Y of t is equal to x1 of t minus 2 convolved with x2 of minus t plus 3. See, Laplace transform I have to find out. Now, first of all, what is done between these two signals? If I call x1 of t minus 2 as first signal, x2 of minus t plus 3 as second signal, what is done between these two signals? Convolution is done, and we know that convolution in time domain is equivalent to multiplication in s domain. So y of s is nothing but the multiplication of the Laplace transforms. So let's find out the Laplace transform of x1 of t minus 2 and x2 of minus t plus 3. Now x1 of t minus 2 Laplace transform, how to get? Only shifting is there. From x1 of t go to x1 of t minus 2. Now x1 of t means what is the Laplace transform? x1 of s. Now shifting means e power minus 2s multiplied with x1 of s. E power minus 2s multiplied with x1 of s. I got the Laplace transform for the first signal, x2 of minus t plus 3. How to get this x2 of minus t plus 3? Use first shift then scale. Shifting is there, scaling is also there, no? So the path will become, start with x2 of t, go to x2 of t plus 3, first shift, call this as some y of t, scale this y of t by minus 1, so that you will get x2 of minus t plus 3. What is the Laplace transform for x2 of t? It is x2 of s, x2 of t plus 3, use your shifting property, e power 3s into x2 of s. Now y of t Laplace transform I know. Now I want the Laplace transform for y of minus t. Use time reversal property. If you reverse in time domain, you have to reverse in s domain. So wherever you have s, replace with minus s. So e power minus 3s into x2 of minus s. So Laplace transform for the second signal is e power minus 3s into x2 of minus s. So overall Laplace transform y of s became e power minus 5s, because here e power minus 2s, here e power minus 3s. So e power minus 5s multiplied with x1 of s multiplied with x2 of minus s, or y. What is x1 of s? x1 of t is e power minus 2t of t, no? So x1 of s is 1 by s plus 2. What is x2 of s? 1 by s plus 3, or y of s is equal to e raised to minus 5s, x1 of s 1 by s plus 2, x2 of minus s 1 by minus s plus 3. Along with this, he is asking us to specify the ROC also, right? And we know that for convolution we will take the common ROC. For convolution we will take the common ROC. So you have to consider the common ROC between x1 of t minus 2 and x2 of minus t plus 3. Right? Now what is the ROC for x1 of t minus 2? First of all, what is the ROC for x1 of s? This is sigma greater than minus 2. This is sigma greater than minus 3. Right. What is the ROC for x1 of s? Sigma greater than minus 2. x1 of t is this one, no? Sigma greater than minus 2. Now here if you observe, shifting is done and we know that ROC does not change with shifting. So ROC for x1 of t minus 2 is sigma greater than minus 2. Sigma greater than minus 2. Now let's observe the ROC for x2 of minus t plus 3. Here shifting is done, scaling is also done. Now what is the ROC for x2 of s? Sigma greater than minus 3. Sigma greater than minus 3. Now first shifting is done and we know that ROC does not change with shifting. ROC does not change with shifting. But with reversal ROC changes. ROC is reverse with reversal. ROC is reverse with reversal. Look here. Sigma greater than minus 3. Suppose if sigma greater than minus 3 is there. Sigma greater than minus 3. If this is the ROC. Now what is the reversal? Reversal means, look here, the pole at minus 3 will become the pole at 3 and the right sided ROC becomes left sided. So sigma less than 3. If I take the reversal, so sigma less than 3. Here reversal is done, no? So sigma greater than minus 3, shifting, there is no change in ROC, but with reversal ROC is also reverse, sigma less than 3. Now I got the ROC for x1 of t minus 2 and I got the ROC for x2 of minus t plus 3 also. Now as convolution is done, now I must consider the common ROC between sigma greater than minus 2 and sigma less than 3. Sigma greater than minus 2, sigma less than 3 means minus 2 less than sigma less than 3. This is the final ROC. Sigma greater than minus 2, sigma less than 3. Next question. I want the convolution of these two signals. I want the convolution of these two signals. Or before this, look here, before this you can attempt one more problem also. Look here, if before this, if I ask you what is the convolution of these two signals, observe here. I am giving you the idea. Suppose if I want the convolution of these two signals. Now can you find out the convolution of these two signals using Laplace? Yes, we can find out. Observe here. So if you want to find the convolution of these two signals, calculate their Laplace, multiply their Laplace. To the resulting Laplace transform, find out the inverse Laplace transform, that is nothing but convolution result. Now, how can you write the first signal? Can I write the first signal as ut minus 1, first signal, convolved with second signal ut minus 1, the same signal. No? Now, multiply their Laplace. So, 1 minus e power minus s by s, 1 minus e power minus s by s, or this is 1 minus e power minus s whole square by s square. Now, if I expand, what will come? 1 plus e power minus 2s minus 2 e power minus s by s square. Right. Now, this is nothing but 1 by s square minus 2 e power minus s by s square plus e power minus 2s by s square. Come on, write the inverse. Calculate the Laplace transforms, multiply the Laplace transform. To the resulting Laplace transform, find out the inverse Laplace. So, 1 by s square means r of t minus 2 r of t minus 1 plus r of t minus 2. Right. Now, we have to draw this signal. We know that in ramp signal, coefficient indicates the slope. R of t means what? Slope is 1, starting point is 0, minus 2 r of t minus 1, slope is minus 2, starting point is 1, r of t minus 2, slope is 1, starting point is 2. So, if I try to draw the resultant, r of t is the ramp signal starting at 0, going with the slope of 1. Slope is positive, means increasing. As this is going with the slope of 1, when it encountered the point 1, a slope of minus 2 is added. What happens if you add a slope of 1 to slope of minus 2? Resulting slope will become minus 1. Now, this is going with the slope of minus 1. As this is going with the slope of minus 1, when it encountered the point 2, a slope of plus 1 is added. What happens if you add a slope of minus 1 to slope of plus 1? 0. So, this is the resulting signal. Here I know the slope, I know this width, I can calculate the height. This is the convolution. Now, try to attempt this one. Actually, this kind of problem came for EC students in digital communication, especially in the topic called matched filter. See, they'll say that this is the impulse response of matched, this is the input to the matched filter. This is input to the matched filter, and you have to find out the impulse response, and after finding the impulse response you have to draw the output. This is the impulse response. And we know that given input and impulse response, output will become the convolution. So write in terms of unit steps, calculate the Laplace transforms, multiply the Laplace transform to the resulting Laplace transform, find out the inverse Laplace. Can you write the first signal in terms of unit steps? S of t. S of t, can you write in terms of unit steps? Sorry, this is 0, this is 1, this is 2. How you are going to write? From 0 to 1 u of t, from 0 to 1 u of t, and at 1 what happened? The value suddenly dropped down from 1 to minus 1. The value suddenly dropped down to 1 to minus 1. So what value? U of t is a signal starting at 0 going with the value of 1. Now at 1 its value suddenly dropped down to minus 1, means a value of minus 2 must be added at the point 1. Now this is going with the value of minus 1. Now at 2 it must be made 0. So already we have seen this kind of synthesizing the given signal in the first unit. This is S of t. Now what is the relationship between S of t and H of t? Here can I write that H of t is nothing but minus S of t? H of t is nothing but minus S of t. Yes. Or your H of t is nothing but minus of u of t minus 2 u of t minus 1 plus u of t minus 2. Simply take the amplitude reversal for S of t. Give a 180 degrees phase shift. Now we know that the output is nothing but convolution. Now we have to find out the convolution. Convolution means calculate the Laplace transforms and multiply the Laplace transforms. So Laplace transforms, u of t means 1 by s minus 2 e power minus s by s plus e power minus 2s by s. So when I am multiplying the Laplace transforms, I am putting the minus symbol in the front. This becomes 1 by s right, or this is what happens if I multiply? What happens if I multiply? If I multiply the Laplace transforms, so minus symbol here, 1 minus 2 e power minus 2s what will come after this? Minus 2 e power minus s minus 2 e power minus s plus 4 e power minus 2s plus 4, somewhat patience is required, plus 4 e power minus 2s minus 2 e power minus 3s plus e power minus 2s minus 2 e power minus 3s plus e power minus 4s by s square, or this is minus of 1 minus 2 e power minus s is there here, minus 4 e power minus s, 1 minus 4 e power minus s, after this e power minus 2s, 4 e power minus 2s plus 6 e power minus 2s Now find out the inverse. Inverse is s of t convolved with h of t is 1 by s square means minus r of t plus, use your shifting property, 4 r of t minus 1 minus 6 r of t minus 2 plus 4 r of t minus 3 minus r of t minus 4. Now we have to draw this one. Minus r of t means slope is minus 1, starting point is 0. And if you want to check if you are going to get everything in terms of ramp, if you add all the coefficients, it must result in 0. So here if I add the coefficient minus 1 plus 4, 3, 3 minus 6 is minus 3 plus 4 is 1, 1 minus 1 is 0. Yes, correct. So here slope is 4, starting point is 1, slope is minus 1, starting point is 4. Now let's draw this signal. How to draw this signal? Observe here. Minus r of t is a ramp signal starting at 0, going with the slope of minus 1. Slope of minus 1. As this is going with the slope of minus 1, when it encountered the point 1, a slope of plus 4 is added. What happens if we add a slope of minus 1 to slope of plus 4? Resulting slope will become 3. Now this is going with the slope of 3. As this is going with the slope of 3, when it encountered the point 2, a slope of minus 6 is added. Resulting slope will become minus 3. As this is going with the slope of minus 3 now, when it encountered the point 3, a slope of plus 4 is added. What happens if you add a slope of minus 3 to slope of plus 4? Resulting slope will become 1. As this is going to slope of 1, when it encountered the point 4, slope of minus 1 is added. Minus 1 plus 1 slopes, if you add, it will result in 0. 0 means slope is 0 means horizontal like this. So this is the resulting signal. Here we know the slope. We can calculate these points also. Here, how to calculate this point? Here slope is minus 1. Here width I know, height I can calculate, it is minus 1. Here also slope is 3. I know the width here, I can calculate the height. Done? Okay, let's look at the next problem. Find the response y of t of an LTI system A if impulse response h of t is equal to 5 e power minus 4t u of t and input x of t is equal to u of t. Try to solve this problem. It is asking us to find out the response y of t of an LTI system given input and impulse response. Use the same principle. Use the same principle. How to find out? We know that given input and impulse response, output is nothing but convolution of input and impulse response. And convolution in time domain is equivalent to multiplication in S domain. Right? Now, how to find out? What is x of s? U of t means 1 by s ROC sigma greater than 0 and h of s 5 by s plus 4 ROC sigma greater than minus 4. So y of s would be 5 by s multiplied with s plus 4. Now resolve this one into partial fractions. How can you write your y of s? How can you write your y of s? If I substitute s is equal to 0, here this becomes 5 by 4 multiplied with 1 by s minus 5 by 4 by s plus 4. Now write the inverse. Y of t is 5 by 4. What is the inverse of 1 by s? For sigma greater than 0, u of t minus 5 by 4. What is the inverse of 1 by s plus 4? E power minus 4t u of t. Five by 4 into 1 minus 4t u of t. This is the output. Clear? Ashok Singh, explain again. I want to find out the convolution. So what I did, I calculated the Laplace transform according to the property, multiplied the Laplace transform to the resulting Laplace transform, find out the inverse Laplace transform. I am doing inverse. That is nothing but convolution result, no? Next question. H of t is equal to 5 e power minus 4t u of t, but x of t is equal to u of minus t. but x of t is equal to u of minus t. Y of t is equal to xt convolved with ht. What is h of s? See, I can find out the convolution of these two signals provided there is a common ROC between these two. Otherwise, I cannot find out the convolution. What is h of s? Phi by s plus 4. Phi by s plus 4. ROC sigma greater than minus 4. X of s is what? U of minus t. What is the Laplace transform? Minus 1 by s. Minus 1 by s, because in the introductory part only we studied that u of t and minus u of minus t will have the same Laplace transform, but they differ in ROC. So minus 1 by s with ROC sigma less than 0. Sigma greater than minus 4, sigma less than 0. Is there a common ROC? Yes, there is a common ROC between minus 4 to 0. Yes, we can find out the convolution. So y of s becomes phi by s plus 4 multiplied with minus 1 by s, or this is minus phi by s times s plus 4. Now resolve this one into partial fractions. What will happen? What happens if I substitute s is equal to 0? S is equal to 0 if I substitute minus 5 by 4 1 by s, partial fractions. S is equal to minus 4 if I substitute. Plus 5 by 4 but here if you observe what is the inverse? 5 by 4. What is the inverse of 1 by minus 1 by s here? Minus 1 by s means u of minus t plus 5 by 4. What is the inverse here? Because we have to take the sigma less than 0 here. Sigma less than 1 by s, sigma less than 0 means u of minus t, and 5 by 4. What is the inverse of 1 by s plus 4 for sigma greater than minus 4? E power minus 4 t u. Or you have to find out the inverse. No, here for inverse 1 by s sigma less than 0 you have to consider. For 1 by s plus 4 you have to consider sigma greater than minus 4. So 5 by 4 minus 1 by s, what is the inverse? U of minus t, right? I think it is minus u of minus t, no? No, u of minus t only, plus 5 by 4 e power minus 4 t u of t. Clear? Please reply so that I can go to the next one. Calculate the Laplace transform, multiply the Laplace transform to the resulting Laplace transform, find out the inverse Laplace transform. That's what we are doing. C. Please reply. 5 e power 4t u of minus t. Problem in partial fractions. After the class you practice. Come on. You have to find out the convolution. First of all, you observe whether convolution is possible or not. So if they have common ROC, then convolution is possible. Then you can proceed forward. Otherwise, you can stop. See, observe here always. Suppose if I have u of t convolved with u of minus t if anybody is asking. U of t convolved with u of minus t if anybody is asking you. So you can proceed with the Laplace transform if there is a common ROC, otherwise you cannot proceed. U of t means what is the ROC? Sigma greater than 0. U of minus t means sigma less than 0. Is there any common ROC? No common ROC means we cannot find out. So this convolution is not possible. See, in the previous examples what we discussed, there is a common ROC, then only we are proceeding. Here sigma greater than 0, sigma greater than minus 4 means yes, there is a common ROC, then only you must proceed. Here also observe here, third one. We know that given input and impulse response, output is nothing but convolution of input and impulse response. Fine. Here what is x of s? 5 e power 4t u of minus t. What is the Laplace transform? We have seen, no? Minus e power at u of minus t. Laplace transform is 1 by s minus a ROC sigma less than a. So here minus 5 by s minus 4 ROC sigma less than 4. ROC sigma less than 4. See, this is h of s, sorry, h of s. What is x of s? U of t means 1 by s, sigma greater than 0. Now you observe, is there a common ROC between these two? Then only you can proceed. Sigma less than 4, sigma greater than 0. Yes, there is a common ROC. Yes, we can proceed. Calculate the Laplace transforms, multiply their Laplace transforms. So minus 5 by, if I multiply s times s minus 4, I think. Now resolve into partial fractions. What will come? Y of s is equal to s is equal to 0. If I put, what will happen? S is equal to 0. Y by 4, 1 by s. S is equal to 4 you put. Here what is ROC? Here sigma greater than 0, here sigma less than 4. Write the inverse. 5 by 4. What is the inverse of 1 by s for sigma greater than 0 u of t? Minus 5 by 4. What is the inverse of 1 by s minus 4 for sigma less than 4? Inverse of 1 by s minus 4 for sigma less than 4 means minus e power 4t u of minus t. Please reply whether you got the same answer or not. Yes or no? Please reply. Okay, next one. D. H of t is equal to 5 e power 4t u of minus t. X of t is equal to u of minus t. Hmm. 5 e power 4t u of minus t, x of t is equal to u of minus t. First of all, he is asking us to find out the output, means you have to use convolution. Whether you can proceed or not, we must observe. We know that given input and impulse response, output is convolution of input and impulse response, right? So what is the h of s? Minus 5 by s minus 4 ROC sigma less than 4. U of minus t. U of minus t means what? Minus 1 by s with ROC sigma less than 0. Is there a common ROC? Sigma less than 4, sigma less than 0. Yes, common ROC is there. Common ROC is there. So we can find out the convolution using the convolution property x of s multiplied with h of s, or y of s is equal to minus 5 by s minus 4 multiplied with minus 1 by s, or our y of s is 5 by s times s minus 4. S is equal to 0 if I put minus 5 by 4, 1 by s, s is equal to 4 you put. Now this is sigma less than 0, sigma less than 4. Write the inverse. Minus 5 by 4. What is the inverse of 1 by s? 1 by s for sigma less than 0? Minus u of minus t. What is the inverse of 1 by s minus 4 for sigma less than 4? Minus e power 4t u of minus t, or overall y of t becomes 5 by 4 u of minus t Please confirm whether you got the same answer or not. Please confirm. Okay. Now h of t is equal to, this is very important, 5 e power minus 4t u of t, whereas x of t is cos t. X of t is cos t. X of t is cos t means here there is an LTI system with impulse response h of t is equal to 5 e power minus 4t u of t, for which the input given is cos t. She is asking us to calculate the output y of t. So we know that given input and impulse response, output is nothing but convolution of input and impulse response. Convolution in time domain is equivalent to multiplication in S domain. But my question is, can you calculate the Laplace transform of cos t? Remember, Laplace transform of cos t does not exist. See, cos omega naught t, Laplace transform does not exist, but Laplace transform for cos omega naught t u of t exists. You can find out the Laplace transform of cos omega naught t u of t, but you cannot find out the Laplace transform for cos omega naught t. For these kind of power signals, you cannot find out. See, if I ask you what is the Laplace transform for 1, Laplace transform does not exist again, but you can find out the Laplace transform for u of t. its Laplace transform exists. Now, in such cases, how to find out the output? How to find out the output? Now, you can use the Fourier transform concept. If you remember, in Fourier transform, while discussing the convolution property, I told you that if you have an LTI system with frequency response h of omega, if you are having a LTI system with frequency response h of omega, and if you are going to give a cos omega 1t, a sinusoid, at the output you will get a sinusoid. If a cos omega 1t is input to LTI system with frequency response h, yes, exactly, Fazal. The statement what I am going to write here is the result of eigenfunction property only. If a cos omega 1t is input to LTI system with frequency response h of omega, output will be the same as input, but there will be only change in magnitude and phase. You will have a change in magnitude and phase. Frequency will not change. A sin omega 1t if I give, the output will be a sin omega 1 a times a1 sin omega 1t plus phi. There may be a change in the amplitude and phase, but frequency will not change. Hope you remember, while discussing the convolution in time property of continuous time Fourier transform, we discussed this one, and this is the consequence of the eigenfunction property only. Now, in the present problem, if you observe here, cos t is the input. So, we cannot find out the Laplace transform of cos t, but given these kind of signals, we can find out the output using this concept. But I need the frequency response. Here impulse response is there, no, with us? Impulse response is there. Now, from the impulse response, if I can calculate the Laplace transform, what I'll get? I'll get the transfer function pi by s plus 4. Now, here do one thing. In the place of s, substitute s is equal to j omega. Substitute s is equal to j omega, so that you are going to get the frequency response. Phi by j omega plus 4. Right? Now, I got the frequency response. Phi by 1 by how much? Sorry, phi by j omega plus 4. Phi by j omega plus 4. What is the input we gave? X of t is equal to cos t. So, what is the output we can expect? A cos t plus alpha. There may be a change in amplitude and phase. Now, the unknown amplitude A is nothing but the magnitude of h of omega at omega is equal to input frequency. Here input frequency is 1 radians per second. This is magnitude of phi by 4 plus j omega at omega is equal to 1 radians per second. This is phi by under root 16 plus omega square at omega is equal to 1. This is phi by root 17. In the same way, better you replace this with phi. Phi is equal to phase of h of omega at omega is equal to input frequency. This is phase of phi by 4 plus j omega at omega is equal to the input frequency. This is minus tan inverse omega by 4 minus tan inverse of 1 by 4. Now, substitute a value and phi value here. Y of t is equal to phi by root 17 cos of this is all. Clear? Please confirm whether you got the same answer or not. Please confirm. Calculate the frequency response and use the concept of Fourier transform. Next question. H of t is equal to 5 e power minus 4t u of t and x of t is equal to 1. Input is 1. Input is 1. We have an LTA system with impulse response h of t is equal to 5 e power minus 4t u of t and input to this system is x of t is equal to 1, is asking us to calculate the output y of t. Now, can you tell me, does the Fourier transform 1 exist? 1 is a power signal. For power signals and periodic signals, Fourier transform does not exist. This Fourier transform does not exist. Then how to find out the output? Then if you want to find out the output, use the eigenfunction property. What is the eigenfunction property of Laplace? In the very first class I told you, eigenfunction property is, remember we cannot find out the Laplace transform of 1, but given these kind of signals as input, we can find out the output using eigenfunction property. What is that eigenfunction property? In Laplace, if x of t is equal to e power s naught t, y of t is the same e power s naught t multiplied with h of s naught. Remember, whenever you have this kind of constant signals, you go for eigenfunction property. Now, how can I write 1? Can I write 1 as e power 0 into t? Yes, then my y of t becomes e power 0 into t multiplied with h of 0. H of 0 means calculate the Laplace transform. After calculating the Laplace transform, in the place of s, simply substitute 0. So what will happen? H of s, the transfer function is 5 by s plus 4, y of t is equal to h of 0 is nothing but 5 by 4. This is the output. Please confirm whether you are getting the same answer or not, so that we can move to the next problem. Please confirm. See, a previous question was given like this. A cos t plus alpha. What is the value of a? Come on. What is the value of a? Exactly, Fazal, you're right. One by one plus j omega. One by root 2. One more previous question was given like this. What is the transfer function of zero order hold? Transfer function of zero order hold. What is the transfer function of zero order hold? Zero order hold. We know that from the convolution property, impulse response and transfer function, they form a Laplace transform pair. So if you want to find out the transfer function of zero order hold, first of all you must know what is the impulse response. Remember, this is the impulse response of zero order hold. This is the impulse response of zero order hold. Find out the Laplace. So can you write this in terms of unit steps? Yes, u of t minus u of t minus t. So h of s is equal to 1 minus e power minus st by s. Basically, the concept of zero order hold will come in the practical approaches of sampling, especially flat top sampling. Flat top sampling is there only for EC students. For electrical students, it is not there. So we have, we haven't discussed that. Later we will discuss flat top sampling also. But for the time being, remember that this is the impulse response of zero order hold. Next question. Consider a system, consider a LTI system governed by differential equation d square y of t by dt square plus 3 dy of t by dt plus 2 times y of t is equal to 2 dx of t by dt plus 3x of t. Find the transfer function. Find the transfer function. Transfer function h of s is nothing but ratio of Laplace transform of output to the Laplace transform of input when the initial conditions are assumed to be 0. So applying Laplace, what happens? S is using the differentiation property, s square into y of s plus 3s into y of s plus 2y of s is equal to 2 times s into x of s plus 3 times x of s, or y of s by x of s, which is nothing but h of s, can be given as 2s plus 3 by s square plus 3s plus 2. 2s plus 3 by s square plus 3s plus 2. This is regarding the convolution in time property of Laplace transform. So we have discussed so many things. So whenever there is a common ROC, see here we haven't discussed the concept of ROC because these two are finite duration signals. Definitely common ROC will be there. So directly we calculated the convolution using the convolution in time property. Finite duration signals. Somebody asked me, why sir, why you are not talking about the ROC? Or same ROC they will be having. So I need not discuss the concept of ROC. Fazal, hope you understood. When the signals are of the same duration, ROC will be entire S-plane. So their common ROC will also be entire S-plane. So we need not talk about ROC. Hope you understood, Fazal. See for the first problem, if you observe, look here, this one you can ask, sir, why we haven't considered ROC here. See, the first one is finite duration signal, entire S-plane, and for the second one, sigma greater than 0. So definitely common ROC is there. So I can directly calculate. No, Arvind, maybe tomorrow or day after tomorrow we'll discuss the concept of stability and causality. Next property of Laplace transform. Okay. Next property of Laplace transform is integration in time. Integration in time. Thank you, Arvind. This property says that if x of t forms a Laplace transform pair with x of s with ROC R, then integral minus infinite to t x of tau d tau forms a Laplace transform pair with x of s by s with ROC is equal to R intersection sigma greater than 0. Today I'll be taking up to 9:15. Be patient, my dear students. X of t, x of s with ROC R, then integral minus infinite to t x of tau d tau forms a Laplace transform pair with x of s by s with ROC is equal to R intersection sigma greater than 0. You can, if you want, you can try the proof also. Integral minus infinite to t x of tau d tau. See, whenever you are integrating means what? Impulse response is u of t, and this is nothing but x of t convolved with u of t. X of t convolved, whenever you convolve x of t with u of t, integration will come, no? Because impulse response of integrator is a unit step signal. So whenever you are going to convolve, you must take the common ROC. Just now we have seen from the convolution in time property. So this is ROC for x of t is R and ROC for u of t is sigma greater than 0. So you have to take the intersection. Understood? Integral minus infinite to t x of tau d tau is nothing but x of t convolved with u of t. So for convolution we will take the common ROC. So for x of t R, for u of t sigma greater than 0. Here one application of this property is, what happens if I substitute x of t is equal to del of t? Del of t means what is the Laplace transform? 1. What is the ROC? Entire S plane. Now substitute x of t is equal to del of t here. Integral minus infinity to t del of tau d tau forms a Laplace transform pair with x of s by s means 1 by s. ROC is equal to R means entire S plane intersection sigma greater than 0. But what is integration of impulse signal? Step signal. Forms a Laplace transform pair with 1 by s. Entire S plane intersection sigma greater than 0. Sigma greater than 0. So u of t Laplace transform is 1 by s, no? U of t Laplace transform is 1 by s. Next question. Find the Laplace transform of integral minus infinity to t e power 2 tau sin tau u of minus tau d tau. Come on, try to solve this one. Integral minus infinity to t e power 2 tau sin tau u of minus tau d tau. Try to solve this one. See, if you compare this with the previous one, in the place of x of tau, what do we have? E power 2 tau sin tau u of minus tau, right? So x of tau, let x of tau is equal to e power 2 tau sin tau u of minus tau. Then integral minus infinity to t x of tau d tau forms a Laplace transform pair with x of s by s. X of s by s. Come on. How to find out the Laplace transform x of s? X of s, how to find out? First of all, look here. If you remember, sin t u of t, what is the Laplace transform? Or sin omega naught t u of t. Sin omega naught t u of t, Laplace transform is omega naught by s square plus omega naught square, ROC sigma greater than 0. See, there is other signal which has same Laplace transform as this one, minus sin omega naught t u of minus t, Laplace transform is also omega naught by s square plus omega naught square, but with a reverse in ROC, sigma less than 0. In the same way, can you tell me what is the Laplace transform for sin tau u of tau? Sin tau u of tau. I am replacing t with tau, nothing will happen. So sin tau u of tau, it is 1 by s square plus 1. In the place of omega naught I have 1 now, with ROC sigma greater than 0, minus sin tau u of minus tau. So it will be minus 1 by, not minus 1, it is 1 by s square plus 1, but with ROC sigma less than 0. sigma less than 0. Now come here. Let's get the Laplace transform of x of tau, that is x of s. Let's get, observe here, sin tau u of minus tau. Can you tell me what is the Laplace transform? From this, minus 1 by s square plus 1. What is the ROC? Sigma less than 0. Sigma less than 0. Now, I want the Laplace transform for e power 2 tau sin tau u of minus tau. What property I have to use? Shifting in S domain property I have to use. What is shifting in S domain property saying? If x of t forms a Laplace transform pair with x of s, then e power s naught t into x of t forms a Laplace transform pair with x of s minus s naught. ROC for x of s is r, ROC for x of s minus s naught, r plus real part of s naught. We have solved many problems on this one also. So here x of t, x of s with ROC r, e power s naught, where in the place of s naught what I have? 2. Wherever I have s, replace it with s minus s naught. S minus 2 whole square plus 1. With ROC is equal to r, means original ROC, plus real part of s naught. S naught is what here? 2. Sigma less than 2. Or I can write e power 2 tau sin tau u of minus tau forms a Laplace transform pair with minus 1 by s minus 2 whole square, s minus 2 whole square. S minus 2 whole square plus 1. The ROC is sigma less than 2. Right? Or next step, x of tau forms a Laplace transform pair with, observe here, x of tau forms a Laplace transform pair with, because we considered e power 2 tau sin tau u of minus tau to be x of tau, no? So what will happen? X of tau forms a Laplace transform pair with minus 1 by s minus 2 whole square plus 1 is sigma less than 2. But what is asking? Integral minus infinite to, we want minus infinite to t x of tau d tau. This I want. Forms a Laplace transform pair with, this is x of tau means this is x of s. X of s by s means minus 1 by s times s minus 2 whole square plus 1 with ROC is equal to r, means sigma less than 2 intersection sigma greater than 0, because we have to take the intersection from the property. ROC is equal to r intersection sigma greater than 0. E power so what is the ROC? Sigma less than 2 sigma greater than 0. This is ROC. 0 less than sigma less than 2. Hope everybody got the same answer. Please confirm. Please confirm. Please confirm whether you got the same answer or not. Yes. In this way, we have to get the Laplace transform. So today we have seen only two properties, that is convolution in time and integration in time. Actually we are supposed to discuss the unilateral Laplace transform, which is used for analysis of causal LTI systems by solving differential equations with non-zero initial conditions. We'll get zero input response, zero state response, but as time is not sufficient, we'll discuss those tomorrow, and after that I'll discuss how to judge the causality and stability of a continuous time LTI system using Laplace. And after that we have small problems with which we can close our Laplace also. Hope you enjoyed this today's session, and if you find any textbook, please go to the problems regarding the convolution in time property, right? So remember, convolution in time property, if you have the input and impulse response, you can find out the output using the convolution in time property. Calculate the Laplace transforms, multiply the Laplace transform, to the resulting Laplace transform find out the inverse Laplace transform, provided the input and impulse response have common ROC, otherwise